So let's take a look now at example number 9. Again, I want to find the absolute extrema, the absolute mins, and absolute maxes of this function on the closed interval 0 to 2 pi. Again, the first thing I need to check is that I have a continuous function here. But let's see, x is continuous, that's a polynomial, and 2 sine x, that's just a trig function with the sine in there, which is always defined. So we can see here that clearly f of x is going to be continuous on the interval from 0 to 2 pi. And so it has an absolute min and max on 0 to 2 pi. That's what, again, the extreme value theorem is telling us. So to figure out where those absolute mins and maxes are, we calculate our derivative. So we calculate, let's see, f prime of x here. Oh, this should be super easy. Derivative of x is 1. Derivative of 2 sine x is just going to be 2 cosine x. And there's not much I can do to simplify that. So let's go ahead and see when this is going to be undefined and when it's going to be equal to 0. So we'll say here that very, very clearly f prime of x is never undefined, right? I mean, that's never going to happen. No matter what you plug into the cosine, you always get an answer back. There's no restrictions there. So never undefined. Now, when might it equal 0? Well, f prime of x is going to equal 0 when 1 minus 2 times the cosine of x is going to be equal to 0. Of course, that means that this would happen whenever the cosine of x is equal to, let's see, if I add the 2 cosine x over and then divide by the 2, that'd be my cosine is equal to a 1/2. Well, now I can maybe start thinking about my unit circle and thinking, okay, if my cosine is going to be a 1/2, then that would mean that on my circle I would be kind of working with, I don't know, like a value like here, maybe over there, where my x-coordinate is going to be right at like a 1/2 mark. But what angles, again, face me in this direction? I should be aware that this would be the angle of pi over 3 and 5 pi over 3. And these are angles, again, that work inside of my interval from 0 to 2 pi. And there are no other values. So I can go ahead here and state that this happens when x is equal to pi over 3 and 5 pi over 3. Not bad. I just had a little trig equation there to actually go ahead and solve. So now I can go ahead and I can set up my table just like I did before, where I can put in all my potential candidates. So I'm going to have 0, pi over 3 would be the next biggest, 5 pi over 3, and 2 pi. Remember, you don't have to write these in increasing order. I just like to. Makes it nicer for me. The hard part here is actually evaluating these in the original function. So notice, if I plug in 0, that one's not bad. 0 minus 2 times the sine of 0, that's just going to be 0 overall. But notice that plugging in something like pi over 3 is going to start to get a little uglier, because this is going to be something like pi over 3 minus, let's see, sine of pi over 3 is going to be root 3 divided by 2. So as a whole, this is going to be pi over 3 minus the square root of 3. All right, I'm just going to leave that for the moment. What about 5 pi over 3? Well, this would be 5 pi over 3 minus 2 times, and down here my sine value is going to actually be negative square root of 3 over 2. So this is going to end up as 5 pi over 3 plus the square root of 3. Okay, great. Still have no idea what that value is. And then we can take a look here. Here I'm going to have, if I use 2 pi, this is going to be 2 pi. Sine of 2 pi is 0. So this is going to be 2 pi minus 0. Okay, so just 2 pi. Well, here's where you can see that while I have exact values written down, to help try to figure out which one of these is the biggest and which one of these is the smallest, it might be useful to try to go ahead and get a rough approximation of these values. Like 2 pi is pretty easy. That's just roughly 3.14 doubled, so that's 6.28. But what the heck is pi over 3 minus root 3? Well, if you were to go to your calculator and try to type that in, you could see that this is going to end up being a negative value. So this is going to be negative 0.0 5.685. I'm just trying to do a couple places. If I was to go ahead and do 5 pi over 3 plus a root 3, I'm going to get a value somewhere in the range of like 6.968-ish. So sometimes I may have to do a little bit of typing this stuff into the calculator to get a sense of which thing's bigger or smaller, especially if it's hard to tell. But once I have that, the rest of the question is easy, right? I can see here that f of x has an absolute max of, and the biggest y value here apparently is 5 pi over 3 plus the square root of 3. Notice I need to still state this value exactly here because that is the value that's hit. Of course, I know when that occurs. I'll put that in here as well. This occurs at x is equal to 5 pi over 3. And I can also see here that f of x has an absolute min of, well, here's the only value in my list that's negative. That's automatically then the smallest, and I need to write the exact value. Notice I'm not writing those green numbers. That would not be the smallest value reached. That would be roughly the smallest value reached. And so this occurs, again, at x is equal to pi over 3. So we've seen kind of now in all these examples a bunch of different things that could happen. My absolute min and max could be at both at the critical points. In the last example, they could be maybe, let's see, max was 9, that happened at an endpoint, and the min happened at a critical point. Or it could be like we saw up here in example number 7, that the min and the max occurred at both of the endpoints. So these can really happen anywhere. My list, again, is just telling me all of my potential candidates, and then I can go ahead, find their y values, kind of put them into competition. The biggest guy wins out and is the absolute max, and the smallest wins out for the absolute min. So hopefully even here, when we were working with this complicated trig function, we can see that while things look messy, the technique and the process is fairly similar. Now you can go ahead, of course, and you can practice all the ideas here for section 4.3 in the associated worksheet. And I highly encourage you to do that and start working on that early so that way as we continue to progress throughout this chapter, you will be feeling really confident that you understand all the ideas because this is all going to be stuff that we're going to be building on top of. Of course, if you have any questions, please feel free to shoot me an email or to stop by during office hours.